Ayan. So, in your junior high school and senior high school, the way they teach the Lewis structure is different, di ba? Paano yung ginagawa before, no? Typically, in high school classes, ang ginagawa is that you represent atoms containing its electrons, di ba? Yung valence electrons nila. For example, carbon, 4 valence electrons, di ba? Sa hydrogen, 1 valence electron. So, anong ginagawa niya? You connect the dots, no? You connect the dots or the electrons to form chemical bonds, no? But the case here is that if your molecule is quite complex, that means malaki na yung molecule, it contains charges, no? Doing it this way, no, would be quite uh, difficult, no? Medyo mahirap gawin yung ganitong process, especially for molecules na malalaki na, no? Or yung may mga charges, no? So, the simplicity of this approach, no, yun din yung reason bakit hindi siya ganun ka-applicable to all of the other Lewis structures na. So, hindi ganyan yung approach natin this time, ha? So, hindi ganito yung gagawin nating approach. Yung you show the atom, then yung i-draw mo yung Lewis dot symbols nila or yung valence electrons, no? This time, we will do it the college way, no? Yung better approach, no? Mas maganda yung magiging result nito after. Kasi mas madali siya maunawaan. As for my case, no, kasi when I learned this, no, yung ituturo ko mamaya yung Naso Rule, when I learned that, ang dali na lang mag-Lewis structure, no. So, yun. Kasi even before, during high school, weakness ko talaga yung Lewis structure, no. Pero nag-college ako, nalaman ko yung Naso Rule. Dali lang pala, no. So, yun. So anyway, so let's begin with Lewis structures now. So what are Lewis structures? Lewis structures are just representations of your molecule, diba? These are structures, no, that represent atoms connection in a molecule. No? Para tayo nagka-Khan Academy, no? So, yun. So when you say Lewis structures, these are representations of molecule, no, wherein you can see your atoms connected from one atom to another. So yan, so may connection, no, and they are connected by what, no? So the atoms are connected by chemical bonds, no. So we can see chemical bonds as lines, no, wherein in each lines may dalawang electron doon, no. So yan. So every time you see a line or a chemical bond, that corresponds to 2 electrons. No? Okay. So yan. So why do they create Why do they create chemical bonds? No? Siguro si lecture yung magdi-discuss nun. No? Because ang coverage ni lecture is discussing the types of bonds, yung ionic and covalent. No? So antayin nyo na lang yung lecture mag-discuss na kung bakit ganon na. But anyway, my focus is on Lewis structures na. Okay, pero the reason why they want to form chemical bonds is that for them to achieve stability, no. Sinabi ko na rin yung sagot. When you say achieving stability, they want to follow the noble gas configuration. Okay, so tignan tayo sa periodic table. This time, wag natin pansinin yung D and DF block. No? Wala. Hindi nag-a-apply yung rules natin sa kanila. Itong D and F block. So we're just going to look at the S and the P orbitals, no, or the S and P block. Okay. So all these atoms, itong nasa S and yung nasa P, they want to be stable. No? Kagaya naman ng lahat, 'di ba? 'Di ba tayo naman napapasana all tayo for people na stable yung job, stable yung family, 'di ba? So on so forth na. So yan. So ganun din yung atoms, no. They want to be stable. So, sino ba yung mga stable elements dito? Of course, yung noble gases natin. So, all the atoms here sa left side ng periodic table, they want to be like the noble gases. In order for them to be like a noble gas, it doesn't mean that your atom will transform from the atom itself to another atom. Hindi pwede magbago yung kanyang protons. Okay? Remember that. Ibig sabihin, kung si oxygen gusto niya maging stable, hindi siya pwede maging neon. Ano pwede niya gawin? The oxygen can imitate what neon is doing. No? O yan. Parang tayo lang yan. No? Whenever we idolize a person, no? Or nagsisimp tayo for a person, it doesn't necessarily mean na tayo nagiging K-popper. Ay, ano, na tayo nagiging yung Korean person na gusto nyo. No? Not really. What we do is that we imitate what that persons do, what that person do not. So, ano ginagawa ng tao? Ayun, kung ano-ano yung ginagawa niya, gagawin mo rin, di ba? So, ganun. Even atoms, they do that. No? Ginagawa rin nila yan. For example, si oxygen, it wants to be stable. So, that means, he wants to, the oxygen wants to be like neon. For example, ano gusto niya gayahin si neon. Okay, so ano gagawin niya? So, it doesn't necessarily mean na oxygen will transform into neon. Hindi magbabago yung oxygen atom to neon. What will happen is that the oxygen atom will imitate what's neon is doing. No? So, ano ba yung pwede gayahin niya? Yung electronic configuration. No? So, that's why na-discuss yun last time. Okay. So what happens in chemical reactions is that the electrons are being transferred, diba? Or being shared to atoms, no? And when those electrons are shared, no, what will happen is that yung atom natin, ma-achieve nila yung noble gas configuration, no? Possible na gayahin na nila yung noble gas configuration as long as they form chemical bonds, no? So that's why chemical reactions are possible. Kasi lahat naman ng atom, lahat ng mga yan, they want to be a noble gas, no? So, yun. For them to achieve that, they do two things, ionic bonding and chemical bonding. So, yung lecture na yung bahala mag-discuss doon in depth, no? So, ba't ba ako nabadaan doon? But anyway, so balik na ulit tayo dito. In our Lewis structures, we represent atoms being connected by chemical bonds, no, in a molecule. No? Okay, so the question here is how can we create a Lewis structure? Kasi I know this has been a struggle for some, no, since junior high school. And I will admit, naging ano ko rin to, naging weakness ko to, no. Parang sa Gen Chem 1 ko dati nung college ako. Ito yung topic na mababa yung score ko eh. Ito lang yung nag-iisang topic na mababa yung score ko dati. No? Pero when I reviewed, no, nalaman ko how to make techniques, no. Ayun, umokay na ako dyan, no. So, masaya na siya. Akala ko kasi dati yan ba yun? Drawing na naman, di ba? Yun. So this time, tuturo ko yung techniques na natutunan ko rin sa review centers sa mga ibang tao, ibang instructors, no. Okay. So let's begin with the guidelines on how to draw Lewis structures. Okay. Rule number 1 is that for you to be able to draw a Lewis structure, you have to identify, hindi pala identify, categorize na your atoms. No? When you say categorize your atoms, isa-segregate mo yung atoms based on its type. No? So, ano ba yung mga types ng atom in a Lewis structure? First, we have the central atom. And then we have the terminal atom. So, what's the difference between the two? No? Okay. So when we say central atom, this is the atom in which all the other atoms will be bonded to. Ito yung kakabitan ng lahat ng atom. No? So, kumbaga, siya yung center ng framework. No? So, sa kanya kakabit lahat ng other atoms, yung let's say hydrogens, oxygens, no? Sa kanya didikit lahat. No? So, what is the criteria for an atom to be a central atom? Madali lang. No? You have to check if that atom is least electronegative sa iyong group. No? Kapag siya yung least electronegative atom. Although this excludes hydrogen. Okay, so again, central atom. This is the least electronegative atom in your molecule. Mamaya, bigyan natin yung example. Let's rationalize muna why we have to exclude hydrogen atom. Okay. Ganito kasi. Tingin tayo dito. If you're going to check the electronegativity, no? So, let's say carbon and hydrogen, no? Sila kasi madalas makikita natin sa organic chemistry. So, on Pauling's scale, no? Pauling scale natin, electronegativity of carbon is 2.55. Hydrogen is 2.20. So, does that mean na si hydrogen yung magiging central atom natin? Ganun ba yun? Not really. Bakit? Kasi, remember that hydrogen only contains s orbital. Diba? Sa first period, s orbital lang meron dyan, diba? Diba? 1s. Sa second period, dito na may 2s and 2p. Okay. So the s orbital cannot hold more than 2 electrons. So it cannot serve as the central atom. Hindi siya pwedeng maging central. That means, never natin makikita na yung hydrogen ay bonded with other groups, no? Walang ganyan, no? Kasi pag ginawa nyo yan, magagalit yung lumikha ng lahat ng atoms, no? So, yeah. Walang ganon. So, hydrogen will never be a central atom for the reason that it can only hold 2 electrons. Anything in excess, hindi pwede. No? So, s orbital lang kasi meron siya. 1s orbital. So, hindi pwede siya kumuha ng more than 2 electrons. That's why, ang H, kaya niya lang mag-form ng single bond. Wala rin kayong makikitang double bond na H na walang ganyan. Kasi, 2 electrons lang kaya niya. Okay? And again, sa isang bond, sa isang line, ilang electrons uli? Dalawang electrons. Keep that in mind, ha? Okay. So that's our first category. No? The central atom, which is the least electronegative atom of all the other atoms, and that excludes hydrogen. No? Okay. So kahit ito yung least electronegative atom, hindi siya yung central. Okay. So if we have a central atom, ano naman yung terminal atom? This is the opposite of your central atom. This is the most electronegative atom naman. So, siya yung mas electronegative, no? Okay? So, this time, si hydrogen, pwede siyang gawing terminal atom, no? Ayun nga, no? Kasi hindi siya pwede kabitan ng iba. So, siya na lang yung kakabit. So, ganun yung idea. So, central atom, this is the least electronegative atom. Terminal atom, this is the most electronegative atom. Once you are able to characterize your atoms, you can draw the skeleton, no? Skeleton. So, paano yung pagdodraw ng skeleton, no? Usually, we surround our terminal atoms, no? Nakapalibot sila sa central atom, no? For example, let's try CH4. For this example, sino yung least electronegative? Si hydrogen yon kasi yun yung sinabi ko kanina, di ba? On Pauling scale, carbon is 2.55. Yung chinek na sa periodic table. No? You can also check that sa periodic table nyo. Carbon is 2.55. Hydrogen is 2.20. So, does that mean that hydrogen should be the central atom? Not really. Because sabi rin dito sa rule natin, excluded si hydrogen sa pagiging central atom. So that means kung hindi hydrogen yung central atom, edi si carbon yung central atom. Ayan, gising na yung pusa ko. So, ano na gagawin natin? No? Ang gagawin natin is that since na-identify natin that carbon will be the central and the hydrogen will be the terminal, ang gagawin natin, we can draw the skeleton. So, how do we draw the skeleton? So, ganito lang. You draw the central atom sa gitna and then you surround it with terminal atoms. So, paano isusurround yun? No? So, ilalagay mo lang siya sa four corners. No? Pwedeng sa top, sa bottom, sa left, and sa right. No? Sir, pwede ba dito? Pwede ba ganyan? Kayo bahala. No? Kayo bahala. No? Pero, ideally, ganyan muna yung pag-arrange. Again, so paano ina-arrange? You arrange your terminal atoms on the four corners of your central atom. No? Sa top, sa bottom, sa left, and sa right. No? Okay. So, once you are able to draw the skeleton, you can do now the Naso Rule. Ito yung natutunan ko na technique, no? Yung Naso Rule. Okay, so I don't know if familiar kayo, no? Pero when I was teaching senior high school, ganito talaga tinuturo ko sa kanila Naso Rule. Para feel nila college na sila, no? Enjoy naman sila. Okay. So, Naso. So, Naso stands for N, needed electron. A is available electron. S is shared electrons. And U is unshared electrons. Okay. So, isa-isahin natin. When we say needed electron, ano yan, no? This tells you about the number of electrons needed for the atom to be stable. Electrons, number of needed for an atom to be stable. Okay, so yan. So yan yung idea. Yan yung dami ng electrons that your atom needs in order for it to be stable. Again, our connotation, when we say stable, to follow yan, the noble gas electron configuration. Okay, so yun lang yung idea ng stable. Once na sinasabi natin stable, hindi meaning nun magiging mayaman yung atom, no? Gusto niya maging noble gas configuration or giyahin yung electron configuration ng noble gas. Okay. So, the question here is, ilang electrons kaya, no? Ito yung octet rule. Ito yung octet rule natin, no? So, yan. So, yung needed electron, this pertains to the octet rule. Ano uli yung octet rule? It tells us that an atom requires 8 electrons for it to be stable. Sir, is that true for all atoms? Not really. But for most, no, yung may examples natin ngayon, yun yung gagamitin natin. No? Sir, bakit naging octet rule? Okay, so ito yung reason why. So, again, we will disregard D and F orbital as they do not follow the octet rule. Pag diniscuss natin to, baka maging BS Chem kayo. No? 18 electron rule kasi dyan. No? But anyway, so looking at S and P orbitals, okay. So bakit 8? Hindi ba pwedeng 9? Kasi lucky 9 o kaya 99 sale sa Shopee or Lazada. Ganito ang reason. So, counting the groups, no, from S to P, ilang groups meron? Bilangin natin, no? So, this is 1, this is 2, this is 3, 4, 5, 6, 7, 8. No? So, we have 8 groups. No? And again, base sa idea ng electron configuration, each group corresponds to a certain orbital. Ito, S1 orbital, S2 orbital, P1, P2, P3, P4, P5, P6 na. So, yan. So, yun yung idea. So, ito yung S1 orbital, S2 orbital, P1 orbital, P2, P3, P4, P5, P6, di ba? Okay. So, the question is, ilang electrons ang kailangan para maabot yung neon, argon, krypton, xenon, radon, o ganeson? Ilang electrons para ma-reach nila yon? 8, no? So, each step, no, from left to right, that corresponds to 1 additional electrons. Okay. So, isang electron, 2, 3, 4, 5, 6, 7, 8. 8 electrons yung kailangan in order for it to be a noble gas, no? Para magaya niya yung noble gases natin, no? So, yun yung reason bakit octet. Why 8, no? Bakit 8? Kasi it has to fill the s orbital and the p orbital completely. Ilang electrons meron sa s? 2. Ilang electrons meron sa p? 6, 'di ba? Hanggang p6  'yun eh, 'di ba? So 'yun. So 2 plus 6 is 8, no? So when the 8 electrons, no, ay fulfilled, that means your atom is now assuming the noble gas configuration. Ginagaya na nila 'yan, no? That's why we have the octet rule. Again, when you say octet rule, ano yan? 8 electrons in order to fill the S2 and the P6 orbitals. No? Yan. That translate to 8 electrons kasi. Okay? So, yun na yung mga nag-violate dyan. No? Okay. Unahan na natin ang isang violation. No? Ang nag-violate sa octet rule is the atoms that contain less than 8 electrons. No? Sino yan? Yung hydrogen, for example. Yung other examples, next meeting siya. No? So, ngayon, basics muna tayo. Okay. So, looking at hydrogen, again, it doesn't contain any p orbital. So, that means it is not required for hydrogen to follow the octet rule. Kasi, ilang electrons lang kaya niya? 2. Huwag pilitin yung hindi kaya. No? So, 2 lang yung kaya ni hydrogen na electron. So, hindi mo pwede ipasak yung 8 electron sa kanya. Magagalit yan. No? So, yan. So, hanggang 2 electrons lang for hydrogen because it only contains the s2 orbital or the s orbital. But for other atoms na nasa p orbital, so, octet rule na sila. Okay, so again, ano yung shortcut natin? As long as you can see the atom on the p orbital, that means it can follow the octet rule. Sino ba usually yung nagpo-follow ng octet rule? Itong mga nasa p orbitals. No? Sino specifically? Carbon, nitrogen, oxygen, fluorine. Sir, paano si boron? Paano itong nasa baba? Saka na yan. No? Next meeting yung discussion then. Okay? So let's try to make things simple muna. Okay? So as long as you see the atom in the p orbital, that should give you an idea that they must follow the octet rule. Okay? So yun yung idea with the needed electrons. Okay? Needed electrons, that is the number of electrons needed for an atom to be stable, aka the octet rule. But not all follows the octet rule, di ba? For example, hydrogen. Ilan yung kailangan ni hydrogen? 2. Bakit 2? Because it only contains the s orbital and for you to completely fill the s orbital, 2 electrons ang need. No? Okay, so that's the end sa Naso. A, available. When we say available electron, this pertains to the valence electrons. Now, Sir, what is a valence electron? Valence electrons are the electrons found in the outer shell of your atom. Meaning nun, sila yung electrons on the outer part ng atom. No? Kasi dalawa yung uri ng electrons eh. We have the inner electrons and the outer electrons. No? So, sino sir yung mga inner electrons? Okay, so for example, let's try sodium. Ang electron configuration ni sodium ay 1s2, 2s2, 2p6, 3s1. Okay? Paano natin malalaman kung ano yung mga inner electrons? Okay. When you say inner electrons, these electrons correspond to the noble gases configuration. For example, 1s2, that corresponds to helium. 1s2, 2p6, that corresponds to neon. Kaya makikita nyo sa periodic table, we can rewrite this as neon 3s1. Meaning lang nun, etong electrons na to, itong nasa 1s2, 2s2, 2p6, they are the inner electrons, no? Paano uli nalalaman kapag inner electrons? You just trace, no? Kung anong noble gas yung kanilang nire-represent, no? For example, ayan, no? Anong noble gas nire-represent ng 1s2? Helium. Anong noble gas ang nire-represent ng 1s2, 2s2, 2p6? Neon. Then, anything outside that range, no? Outside this bracket, that is the valence electron. So that means for sodium, we have one valence electron. So we can represent that as one electron or one dot. No? One dot, totropahin, jojowain. So yan. So isang valence electron lang meaning nun. No? Pag may nag one dot, valence electrons yon. Isa pang example, oxygen. The electron configuration of oxygen is 1s2, 2s2, 2p4. Okay. So, yun yung kanyang electron configuration. Again, if you want to determine the inner electrons, you have to check kung alin dito sa mga electron configuration ang nagko-correspond with a noble gas configuration. Yung 1s2, that's helium agad. Can we say na ito ay neon? Not really. Bakit? For it to be neon, kailangan 2p6 yung nasa dulo. Kaso hindi eh. So, that means the inner electron is the 1s2 lang, no? So, that means we can rewrite this as helium 2s2, 2p4. Okay. So, these electrons outside the inner electrons, ito yung ating mga valence electrons. So, ilan yung valence electrons ni oxygen? Para bilangin, 2 plus 4, 6 lang yan. So, we represent oxygen as an atom containing 6 dots, no? So, hindi na siya 1 dot, no? 6 dots na. So, usually nire-represent yun as 1, 2, 3, 4. Then, kapag sumobra na sa 4, mag-pair ka na, 5, 6. Okay? So, ganyan. So, yan. Sir, ano ba yung shortcut for us to determine the valence electrons? Madali lang, no? If you want to check the valence electrons easily, all you have to do is look at the group of your atom in your periodic table. Okay, so paano tayo, sir, magbibilang ng group? Okay, so we will disregard the D and the F orbital again, no? So we're just looking at the S and the P orbital. If your electrons or if your atoms are located on the group 1A, meaning nun, 1 yung valence electrons nila. 1 dot yan. Pag group 2A, yan ay ilang dots? 2 dots na. 2 valence electrons. Ito, group 3 to, no? Ang ginawa lang ng periodic table na to is yung modern interpretation. Pero punta tayo sa basic interpretation. Main group. Itong group ni boron, ito yung group 3. 3A tawag dyan eh. Group 3A. Pag nasa group 3A ka, you have 3 valence electrons. Group 4A, carbon family, 4 valence electrons. Group 5 or nitrogen family, 5 valence electrons. Ito yung 6, no? Yung oxygen. Yung ginawa natin kanina, di ba nakita natin na 6 yung valence electrons niya. Okay. So oxygen family contains 6 valence electrons. Group 7 or the fluorine family, they all contain 7 electrons, and group 8, they all contain 8 electrons except for helium na dalawa lang. Okay? So again, what's the shortcut for you to check kung ano yung kanilang valence electrons? All you have to do is to just look at which group it is located, no, in the periodic table. Pag nasa group 1 yan, 1 valence. Group 2, 2 yung valence. Group 3, 3 yung valence. Group 4, 4 yung valence. Group 5, 5. Group 6, 6 valence. Group 7, 7 yung valence. And group 8, 8 yung valence. Okay? So, yun yung shortcut natin. So, you do not need to do this thing na, no? Hindi mo na kailangan gawin yan, no? So, titingin ka lang sa periodic table, no? Life hacks, no? Alam ko naman, alam nyo na yan, no? I just want to remind lang. Okay? So, yan. Yun yung ating valence electrons, no? Okay. Balik ulit tayo sa Naso. S, shared electrons. Sir, ano yung shared electrons? Okay. So, remember, your atoms in molecules, no? They share electrons, no? In order for them to achieve stability, meaning non to satisfy the octet rule. So when we say shared electrons, these are the electrons used in chemical bonds na. Ito yung mga electrons na ginagamit sa chemical bonds sa mga line. No? Again, how many electrons per bond? Per bond, that corresponds to 2 electrons. Okay. Paano namin, sir, malalaman yung shared electrons and how many bonds can we form from that na? So, may simple formula lang tayo. To get the number of shared electrons, all you have to do is to subtract the needed electron and the available electron. So, pag susubtract mo lang silang dalawa na. So, by subtracting them, you will get the shared electrons. Kung ilang electrons yung gagamitin to form one bond. Okay? If you want to determine how many bonds ang kaya, you divide the shared electrons by 2. Because again, one bond corresponds to 2 electrons. Mamaya, makita nyo yung example nito. Unshared. Okay, so sa ating Lewis structures, we can see the unshared electrons as lone electrons. When you say lone electrons, these are electrons that are not used in chemical bonding. Ibig sabihin, hindi sila ginagamit sa paggawa ng bonds. No? So, lone electrons not used in bonding. So, sila yung nakikita natin as lone pair. Yung dalawang tuldok. No? 2 dots na siya. No? So, how do we know kung gaano karami yung unshared electrons? The formula is A minus S. You subtract the available and the shared electrons. By subtracting them, you can get how many electrons no, are unused. No? So, ilan yung magiging lone electrons? Sila yung ipag-pair mo to form the lone pairs. Okay? So, with that, no, we're done with the Lewis structure. You choose the central atom and the terminal atoms. You draw the skeleton. Again, when drawing the skeleton, place your atoms around the central atom, no, on the 4 corners of your central atom. Then you do the Naso rule. No. The needed electrons corresponds to the Octet rule, if needed. No. Available, that corresponds to your valence electrons. Shared electrons, that corresponds to how many electrons are used in forming chemical bonds. Unshared electrons, this tells us about the lone electrons or the electrons unused in chemical bonding. Siguro sa ngayon medyo cloudy pa yung idea, no? Okay, so as we walk through 5 examples today, medyo magiging maliwanag siya, hopefully, no? So I will start drawing Lewis structures with CH4. Gamitin na natin yung Naso Rule para mas malinaw kung ano yung mga meaning ng pinagsasabi ko kanina. Okay, so let's begin with CH4. The first rule is for us to identify kung ano yung central atom. So, sino kaya yung central atom? Again, hydrogen is not a central atom despite of its electronegativity being less than that of carbon. Mas least electronegative si hydrogen, yes, pero hindi siya pwedeng central. So, si carbon lang pwede. So, you draw your carbon on the center and all your hydrogens will surround the carbon na on the four sides na. Yan. After doing that, yung nagawa na natin yung skeleton natin, we can proceed with the Naso Rule. Okay, Naso. Needed. Okay, so pag kukunin natin yung needed electrons, we have to check yung individual atoms. Ilang electrons ba gusto nila? Tanungin natin si carbon. How many electrons ang needed ni carbon? Ang one way to rephrase that question is ito. Nagpa-follow ba ng Octet Rule si carbon? Nagpa-follow ba siya ng Octet Rule? The answer is yes. Bakit siya yes, no? Kasi looking at the periodic table, carbon is in the P block element, no? So basta nasa P block, it should follow the Octet Rule. Most of them follow the Octet Rule, no? So carbon follows the Octet Rule because it is in the P block, no? So it can hold 8 electrons na because of the presence of the P orbital na. So carbon, Octet Rule yon. Times kung ilang carbon atoms meron tayo. So 8 times 1. Next one, hydrogen. Ilan yung needed ni hydrogen to completely fill its orbital? Dalawa lang. Because again, hydrogen only contains s orbital. And s orbitals, no, can only occupy 2 electrons. So 2 lang yung needed niya. Times ilang hydrogen atoms meron tayo? 4. So to get the number n, ipag-add lang natin yan, no? So 8 times 1 is 8. 2 times 4 is 8. 8 plus 8, 16 electrons. So our molecule needs 16 electrons na. So yan yung needed. Okay, so ganun. Tapos na tayo dyan. A, available. When we say A or available, that pertains to the valence electrons. Okay, so meaning lang nun, we are going just to check, no, kung anong group siya sa periodic table. Carbon is group group 4 sa periodic table. Paano uli yung counting? This is group 1, group 2, group 3, group 4, group 5, 6, 7, 8. So carbon is in group 4. So the valence electrons of carbon is 4. Hydrogen, siya ay nasa group 1. Times ilang hydrogen atoms meron? 4, no? So you add them, no? 4 plus 4 is 8 electrons. Okay. So ganun lang, na? Again, N, ito yung Octet Rule. A, ito yung valence electrons. To get the S or the shared electrons, you're going to subtract N minus A, the needed minus the available. So that's 16 minus 8, 8 yon, 8 electrons. Saan gagamitin yung 8 electrons? They will be shared in the form of chemical bonds, no? Question. Ilang chemical bonds ang kaya with 8 electrons? So, ano uli ginagawa? You just divide it by 2, no? Divide mo lang siya 2. That will give you 4 bonds. Bakit divide sa 2? Kasi, yung 2 electrons, they will make 1 bond, no? So, that means 8 electrons can form 4 bonds. With the idea on S, pwede na tayo gumawa ng bonds, no? So, 1 bond, 2 bond, 3 bond, 4 bond. Ayan, so it seems na tapos na tayo, no? So, nalagay na natin yung bonds, no? Okay. So, U is unshared. Again, unshared pertains to the lone electrons or the lone pairs, no, of electrons. To solve for the number of lone pairs or unshared electrons, all we have to do is to subtract the available and the shared electrons. So, 8 minus 8 lang yun, no? Available minus shared. 8 minus 8, 0. That means no lone electrons or no lone pairs, no? Okay, so with that, we're done drawing CH4. So, ganyan na yung itsura niya. We have 4 electrons, 4 bonds rather, no? We have 4 bonds, no? Shared between carbon and hydrogen atoms, no? So, yan. So, how can you verify if tama na yung drawing nyo? So, ganito. Zoom in tayo dyan. To verify kung tama na yung drawing natin, balikan natin yung N, yung needed. 'Di ba sabi natin, carbon needs 8 electrons for it to be stable. Paano mo siya i-check dito? Ganito. So, you're going to draw a border sa carbon, no? Encompassing or enclosing all the bonds, no, na nakapalibot sa kanya. Meaning, papalibutan natin ng border yung bonds na nakadugtong kay carbon. So, ganyan yung meaning ko. You will enclose all the bonds na nakadikit kay carbon using gamit ang border. No? So, bilangin mo kung ilang electrons yung nabilugan natin. Again, pag may isang line that corresponds to 2 electrons. So, how many electrons are there around the carbon? 2, 4, 6, 8. So, is the Octet Rule satisfied? Nasatisfy ba natin yung needed na 8? Yes po, kasi we have 8 electrons around carbon. So, yan. So, that means okay tayo dyan. How about hydrogen? How about hydrogen? Again, to check if tama yung dami ng electrons around hydrogen, you have to draw a border enclosing the end of the bond. No? So, i-enclose mo yung end ng bond. No? Gagawa ka ng mga parabola. So, gagawin natin, we will count how many electrons are enclosed, no? Dito kay hydrogen. So, for this hydrogen, we have 1 line or 2 electrons. So, satisfied na ba yung needed niya? Diba ang needed niya, 2 lang? So, the answer is yes, satisfied na yung needed. Ito, satisfied na ba yung needed niya? Yes then, kasi may isang bond or may 2 electrons na nakapalibot sa kanya. For this hydrogen, 2 na rin. This hydrogen, 2 na rin. No? So, after confirming that we are following the needed electrons for each atom, that means okay na yung structure natin. So, pag nakita mo na 8 na yung nakapalibot kay carbon, ay, ba't ko binura? Pag 8 na yung nakapalibot kay carbon, okay ka na dyan. No? Kapag ano na nangyari? Yeah. Kapag nakita mo na tigda-2 na yung nakapalibot kay hydrogen at na-confirm na tama na yon, no? That means you're done with the structure, no? Okay, so may 4 examples pa tayo to further strengthen the idea of the Naso Rule, no? So let's try number 2, CF4. CF4. Okay. So, sino yung central atom dito? So, let's check the electronegativities. Fluorine is the most electronegative, diba? Because looking at the periodic table, the electronegativity increases from left to right and bottom to top, no? So, si fluorine yung most electronegative than carbon. So, that means fluorine, being the most electronegative atom, siya yung siya yung magbe-bear ng terminal side, no? So that means fluorine would be our terminal, carbon would be our central. So lagay mo si carbon sa gitna and your fluorines will surround the carbon, no? On four sides. After doing that, Naso Rule. Okay. So N, again, this pertains to the lone electrons na. Ay, hindi. I mean, N, this tells us about the octet rule, di ba? So for carbon, does it follow the octet rule? The answer is yes, because it is in the p orbital. So carbon always follow the octet rule. So 8 times 1. Saan galing yung 1? Number of carbon atoms. Okay? For fluorine, ano yung kanyang fina-follow? Nagpo-follow ba siya ng octet rule? Yes then, because fluorine is in the p orbital, no? So as long as nasa p orbital, it should follow the octet rule, no? Most of the time. So 8 times how many fluorine atoms? 4. So all we have to do is just to add them up, no? So 8 plus 8 times 4. So that's just 8 times 5, 40 electrons. So there should be 40 electrons in our molecule now. A, available. Again, when we say available, that pertains to the valence electrons. Okay. So carbon, since it is in group 4, that means it contains 4 valence electrons now. 4 yung valence electrons niya. Fluorine, since it is in group 7, so 7 times 4 lang yan. Okay, so all we have to do is to multiply it now. So 7 times 4, 7, 14, 21, 28, plus 4, 32 electrons. Okay, so ganun. Again, saan galing yung 4 and 7? They all came from the group number of your atom. Because the group number corresponds to your valence electrons. Okay? So yun yung idea. Shared. Again, the formula for shared is N minus A. So that's 40 minus 32. That's 8 electrons. If you want to know how many bonds yan, you just divide it by 2. Okay, so we will get 4 bonds now. Okay, so once alam nyo na kung gaano karaming bonds, you can start connecting your atoms. No? 1, 2, 3, 4. So nagamit na natin yung 4 bonds. No? Sir, paano kapag kinulang yung bond? No? Pag kinulang yung bond, mali, no? So baka may nakalimutan ka dito sa N pati sa A. Sir, paano kapag sumobra? Okay lang yan sumobra. May example tayo dyan mamaya. Okay. So yan. So N minus A, 8 electrons or 4 bonds. No? Sila yung shared electrons. How about U? U is the unshared electrons. So paano natin isasolve yan? No? So that is A minus S. So A minus S. So that is 32 minus 8 na. 32 minus 8. So ilan yon? 24. Tama ba? 24. Or, in terms of lone pairs, ilan kaya yon? No? Pwede kasi natin ipag-pair yung lone electrons to make a lone pair. So, all we have to do to identify kung ilang lone pairs yan, divide mo lang yan sa 2. So, we will have 12 lone pairs. No? May 12 tayong pair ng electrons. Okay, this time may lone pairs tayo. Saan natin ilalagay sila? When you are going to place your lone pairs, no, you have to you have to place it muna on the terminal atoms. Terminal atoms muna. Terminal atoms before you go sa central, no. Kapag may natira sa central, okay? So, paano tayo sir maglalagay ng lone pairs? Okay. Make sure when placing electrons, you still follow the octet rule. You still follow the 8 electrons needed for that atom. So, distribute natin yung 12 lone pairs. So, I will start with this fluorine atom. Again, terminal muna before the central. So, how many electrons are there already around fluorine? There are 2 electrons around fluorine na, no? So, dalawa na yan eh. So, ngayon, ilan pa kailangan for it to follow the octet rule? So, that is 8 minus 2, yung meron na, dalawa na. So, 6 pang electrons yung kailangan. Yung 6 electrons needed, kailangan siya i-convert into lone pairs, no? So, ilang lone pairs yung 6? Making 3 lone pairs yun. So, 1, 2, 3 lone pairs, no? Then, after placing the lone pairs, you count again. Kompleto na ba yung octet niya? 1, 2, 3, 4, 5, 6, 7, 8. Again, yung bond, dalawang electron katumbas niyan. So, looking at this fluorine, okay na yung acting octet rule sa kanya. Okay, so that means we're done with this fluorine atom. Pero, sobra pa rin tayo ng lone pairs. No? We still have excess lone pairs. So, we have to continue distributing it until ubos na siya. So, let's look at this fluorine. How many electrons are there already? 2. Itong bond, no? How many lone pairs can we place sa fluorine? 3 din, no? So, by placing 3 lone pairs, we can have 8 electrons around this fluorine atom na, no? So, 1, 2, 3, 4, 5, 6, 7, 8. So, kompleto na yung kanyang octet rule. Again, may sobra pa tayong 6 na lone pairs. No? Kasi di ba 12 yung meron tayo. We used 1, 2, 3, 4, 5, 6 na. So may 6 pang natitira. So let's look at this fluorine atom again. So ilang electrons na meron around it? 2. How many lone pairs can be placed for this atom, for fluorine? 3. So 3 lone pairs. So, bilangin natin if it follows the octet rule already. No? So, this is 2, 4, 6, 8. No? Okay, so, okay na siya sa octet. Then, yung last 3 lone pairs natin, lalagay ko na rin dito kay fluorine. No? So, to verify, it will follow the octet rule. So, bilangin mo kung ilang electrons na yan. 2, 4, 6, 8. No? So, with that, no, we already distributed all the lone pairs sa terminal atoms. Ubos na yung lone pair natin. Okay, so with that, our structure is almost complete na. So all you have to do is just to verify kung na-follow yung N sa Naso. 8 for fluorine. So ginawa na natin yon while we are distributing the lone pairs. Yung 8 sa carbon, bilangin din natin. No? So again, when counting the electrons around carbon, you draw a border enclosing all the bonds na. Nakasarado yung bonds. Ilang electrons yan? 8, no? So this is 2, 4, 6, 8. So that means we already followed the needed electrons for carbon and fluorine. 8 for carbon, 8 for fluorine, and with that, no, our structure is already complete na. Okay, so ganun lang yung idea. Another example. If you have questions, you can chat no, you can use the chat box, no? Or you can use your microphones para alam kong gising pa tayo. No? Baka mamaya tulog pa pala kayo eh. Okay. So I will proceed with NF3 na, no? If may hindi clear, just lagay nyo sa chat box, no? Don't hesitate. Okay. So let's go sa third example, NF3. Okay. Identify the central atom. Ito, magtatanong na ako sa inyo. You can use your microphone. Sino yung central atom natin?
N po, nitrogen.
Because it has the least, it has the lowest electronegativity, di ba? Again, yung trend kasi, on the right side, electronegative. Sa left side, di masyado. Share ko lang, yung di masyado sa Spanish, no? Pag tinagalog niya siya. In English, too much, no? Medyo opposite, no? Pag Tagalog kasi di masyado, ibig sabihin nun, tiny lang. Pag Espanyol, demasiado means too much, no? Ang hirap maging kolonya, no? But anyway, so nitrogen will be our central. F is our terminal, no? Maganda rin mag-aral ng Spanish, no? Nood ka ng Dora, magagets mo si Dora. Bakit ganun siya? So, nitrogen will be the central. Fluorine will be the terminal. So, I will place my fluorine around nitrogen. Okay, so after doing that, Naso Rule. Naso. Urong ko muna dito banda. Ay, bakit ganun? Ayoko na. Brain ko na lang. Okay, so Naso Rule for nitrogen and for fluorine. Nitrogen. Nagpa-follow ba siya ng Octet Rule? Yes or no? You can use your mic na lang. Nagpa-follow ba si nitrogen ng Octet Rule?
Yes po, sir.
Yes po. Because it is in the p orbital. Basta ganun yung technique. If the atom, you can see the atom sa p block or sa p orbital, it should follow the Octet Rule. So 8 times how many nitrogen atoms? Isa. Fluorine. Does it follow the Octet Rule?
Yes po.
Yes po, because it is also in the p orbital, di ba? Or the p block. Times, ilan yung fluorine? 3, di ba? So 8 plus 8 times 3, 8, 16, 24, 32 electrons. So we have 32 electrons needed. Okay. So available, again available, this pertains to the valence electrons. How many valence electrons are there for nitrogen? Ilan kaya?
5 po.
5 because it is in group 5. So 5 times 1. For fluorine,
7 po.
7 because it is in group 7. So add lang natin. 5, 7, 14, 21 plus 5, 26 na. Okay. So after doing that, S. Again, what's the formula for S? N minus A. So that's 32 minus 26. 6 yan na. Or tatlong bonds. Again, you divide it by 2 ha. You divide your shared electrons by 2 to get 3 bonds. Okay, so gagawin na natin yun. No? I will place the 3 bonds to connect my fluorine to nitrogen. No? 1, 1, 2, 3. Okay, so I'm done. Tapos na. U, unshared. So, paano yung unshared? That is A minus S. Available is 26. Shared is 6. So, ilan yon? 20 electrons or how many lone pairs? Divide mo lang yan sa 2. 10 lone pairs. So, I will distribute the 10 lone pairs on my terminal atoms first before the central atom. Okay? So, ganun yung gagawin natin. Terminal muna before the central. And make sure you follow the octet rule when you do that. No? So, yan. So, let's look at fluorine muna. So, we already have 2 electrons for this fluorine atom. How many lone pairs are needed? Anyone? Yes. Yes, Jean Paula. Ilang lone pairs ang need for fluorine?
6 po.
Ano po ulit? May chat. Teka lang. 6 po. 6 electrons or 3 lone pairs na. So, ayan. So, thank you, Jean. So, I need to have 6 electrons pa for fluorine. Or in lone pairs, tatlong lone pairs yan. So, 1 lone pair, 2 lone pair, third lone pair. No? So, isa, dalawa, tatlong lone pairs. And counting the electrons again, I already have 8 electrons for fluorine. No? So, yan. So, I'm done with this. And since yung ibang fluorine atom naman, no, they look the same as this one, edi gayahin mo na lang, no? So, para mabilis, no? Gayahin na lang natin. Isa lang naman itsura nila eh. Okay? So, yan. So, we distributed the lone pairs to all terminal atoms na, no? So, ginaya ko na lang ito kasi iisa lang naman itsura nila. Okay? So, para mabilis, no? Okay, so again, let's count how many lone pairs ang nagamit natin. 'Di ba we have 10 lone pairs, sabi ng U. 'Di ba? We have to distribute 10 lone pairs. So bilangin natin ilan ang nagamit natin. 1, 2, 3, 4, 5, 6, 7, 8, 9. Pag may sumobrang lone pair, again, saan ilalagay? Sa central. So ilagay mo siya sa central. Okay, so once you are able to distribute all the lone pairs, that means you're pretty much done with the Lewis structure, no? All you have to do is just to verify if yung nitrogen, it follows the octet na. Because again, we already followed the octet kay fluorine, no? Na check na natin yung octet rule sa kanya. So, we're left with nitrogen, no? So, to do that, you draw a border encompassing the ends of the bonds, no? So, yan. Hanggang dulo ng bonds, no? So, how many electrons are enclosed, no? So, 2, 4, 6, 8, no? Okay, so we already followed the octet rule for nitrogen and fluorine. So, that means we're done drawing the Lewis structure for NF3. So, ganyan lang, no? Siguro yung iba sa inyo may isip na, Sir, di ba parang mas madali yung ganito? Yung ganitong Lewis structure. Tapos idudugtong mo na lang, no? Ganito ginagawa natin nung high school, di ba? Di ba? Sir, parang mas madali yan, di ba? O, ito yung trick. Paano kapag may charges na yan? If your molecule contains charges, paano na? your simple Lewis structure na ganun, yung Lewis dot symbols nyo, that cannot answer yung charges kasi, no? Hindi na niya masagot. Paano na kapag may charge? Okay. So, with that, no, let's begin with our fourth example. Paano kapag may charge na? Yun yung hindi kaya ng ating Lewis dot symbols, yung ginagawa ng high school. Kaya, if you can check, no, yung ginagawa natin ng high school, walang charges yung molecule, no? So ngayon, college na tayo, kailangan may charge na, no? Okay, so let's begin NO plus. Identifying the central and the terminal atom here doesn't really matter na, for the reason that dalawa lang naman sila, no? Magkatabi lang sila. Magkatabi lang naman sila. So, hindi mo na need i-identify yung central and the terminal, no? Okay, so with that, Naso Rule. Ito yung kagandahan ni Naso Rule, no? It can answer complicated structures. When I say complicated, yung may mga charge, no? Hindi kasi siya kaya ng typical Lewis dot symbol ng high school. So, we will use Naso. Okay, so again, needed. Okay. So, for nitrogen, does it follow the octet rule? Use your mic na lang. Kahit sino pwede magsalita.
Yes po.
Ang pusa ko. Inuubo yung pusa ko. So, nitrogen follows the octet rule. So, that's 8 times 1. Yung oxygen kaya, does it follow the octet rule as well?
Yes po.
Yes po. So, 8 times 8. So, how many needed electrons? 8 plus 8 is 16 electrons. Okay. Available. For nitrogen, ilan po yung available or yung valence electrons niya?
5 po, sir.
5 po na. So, 5 times 1. For oxygen, ilan yung valence electrons niya?
6 po.
6 times 1. Ilan yan? 5 plus 6, 11 electrons. Okay. So, ganito. After writing yung available, tapos nakita mong odd number siya. Kasi tignan nyo yung iba, di ba? Puro even numbers yung meron tayo. Kaya divisible sila by 2. Di ba? Kapag add yung iyong electrons dyan, tingin ka uli sa molecule mo. No? Magduda ka muna. No? So, looking at our molecule, it contains a positive charge. Di ba? Yung molecule na yan, cation yan. No? And again, when our molecule or our atom is positive in charge, ano meaning nun? Sobra ba siya ng electron or kulang siya ng electron kapag positive charge? Recall yung lesson natin last time, yung cations and anions. No? Yung charge, kapag positive yon, sino mas marami? Protons or electrons? Pag positive yung charge, yung protons. Ibig sabihin, onti yung electrons. For molecules naman, pag positive yung charge niya, that means kulang siya ng electron. Okay, the molecule lost electrons, no? Nabawasan siya ng electron, nawala yung electron niya. Ang question that is, how much, no? E di tingin ka dito, ano yung number dyan sa positive na yan? Pag walang nakalagay na number, 1 lang yan. So that means this molecule, no, lost 1 electron. Nawalan siya ng isang electron. And with that, naging positive charge siya. So that means yung available natin na electrons, hindi na siya 11. Kasi remember, positive charge yon. Meaning nun, nawalan siya ng isang electron. So we have to adjust our available electrons pag may charge. O paano natin i-adjust yan? No? Since the idea is that it is positive charge, no? Positive in charge because it lost electron. That means we will deduct the electron lost sa available. Babawasan natin yung available, no? Ng ilan? Ng isa, no? Bakit isa, sir? Bakit isa? Kasi the charge of our molecule is positive 1 na. So, basta positive 1 yan, magma-minus 1 ka sa available. Sir, paano kapag positive 2 yan? Magma-minus 2 ka sa available. Again, opposite yung sign sa. Sir, paano kapag positive 3 yan? That means kulang ka ng 3 electrons. You have to deduct 3 electrons here. Okay? So, yun yung idea. Sir, paano kapag negative charge naman yan? So, when you're, ano, when your molecule is negatively charged, that means may sobrang electron. Di ba remember your atoms, no? When they gain the electrons, they become negative in charge, di ba? Nagiging anion sila. So, ganun din dito sa molecules, no? If this becomes negatively charged naman, yung available nyo, kunwari lang to ha, kunwari negative charge naman siya, that means there is an excess electrons. May sobrang electrons. Ilan po yung sobra? Just look at the number on the exponent. Pag wala nakalagay, 1 yan. No? So, since wala nakalagay, everyday 1 yan. So, meaning yan, there is an excess of 1 electron. So, you have to adjust your A by adding the excess 1 electron. So, magiging 12 electrons yan. So, ganun yung idea. Sir, paano kapag negative 2 yan? That means there is an excess of 2 electrons. So, you have to add 2 dito sa available. So, in summary, whenever you see positive charges, no, you have to subtract the number of positive charge dito sa available kasi kulang ng electron yung idea. Kapag negative charge yung molecule mo, that means may sobrang electron. And you have to account for that dito sa available. So you have to add the excess electron dito sa available. Pag negative yon, magpa-plus electron ka, no? Pag positive, magma-minus ka. Okay? So, yun yung idea. Wag malito sa sign, no? Kasi we are pertaining to electrons, no? Pag positively charged ang molecule, you will deduct electrons, no? Again, because pag nababawasan ng electron, nagiging positive yung molecule, no? Pag negative to, ito, pag negative yung charge ng molecule mo, that means may sobrang electron. That's why you have to add electrons. Don't confuse na lang with the signs, no? Basta isipin nyo kapag negative, may sobrang electron. So, plus electron yon. Okay? Mamaya may examples pa naman tayo. Okay tayo doon. Sige. Basta pag may clarification, you can raise your hand or use the meeting chat. No? Don't hesitate to ask. No? Para hindi sayang yung tuition fee. S, shared na tayo. So again, the formula for shared is n minus a. So that's 16 minus 10. Again, bakit naging 10? Because we accounted for the charge. No? So hindi na siya 11, 10 na siya. So 10. 16 minus 10 is 6 or 3 bonds. Na? 6 electrons or 3 bonds. So saan ko ilalagay yung 3 bonds? In between nitrogen and oxygen. So 1, 2, 3. Ka lang. Ayan, so may 3 bonds na dyan. Ayan yung hindi kaya ng typical Lewis structure nyo. No? Yung ginaganito nyo nung high school. Hindi niya kaya yan. Kasi isipin mo, 1, 2, wala, paano na? O, diba? Ayan. So, hindi niya kaya yan masyado. Unlike Naso Rule, okay lang, no? Kayang-kaya, no? Okay. So, ayan. So, NO. we have 3 bonds. So that means you have to place the 3 lines in between nitrogen and oxygen. Bawal po dito sa side na to. Bakit? Wala naman kasing atom doon eh. So in between the two atoms lang, na. So that means we have a triple bond, no? Then what's next? U. So the formula for U is A minus S. So that's 10 minus 6, 10 minus 6, no? 4 electrons or 2 lone pairs. Again, how do we distribute the lone pairs, no? Gawin mo, you draw a border muna. Then you check if it already follows the octet rule, no? Check mo kung nagpo-follow na siya ng octet rule. For this oxygen, we already have 6 electrons, 2, 4, 6. So, ilan pa ang electron kulang? Dalawa. Or 1 lone pair yon. So, ayan. May lone pair si oxygen. And with that, oxygen now already have the 8 electrons needed, no? So, octet rule na siya. So, sir, saan yung isa pa? Eh di kay nitrogen, no? So, you can verify it by drawing a border again. How many electrons are there around nitrogen? 2, 4, 6. So, 6 na. Ilan pa kulang? Dalawa or 1 lone pair. Okay. So, by doing that, no, we are done drawing the Lewis structure for NO+. Ayan, tapos na. So, ano yung advantage uli ng Naso Rule? We can account for the charges. If your molecule is positive in charge, you have to deduct that positive charge dito sa available. So, if your molecule is negatively charged, you have to add the extra electrons dito sa available. No? So, yan yung good thing with the Naso Rule. You can draw structures of charged particles na madali, no? Easy lang yung pag-draw, no? So, another example, carbonate, CO3, -2. Okay, Naso Rule. Hindi pa tayo magna-Naso Rule. Sino yung central atom? Carbon or oxygen?
Carbon po. Kasi siya yung least electronegative.
So, yes. So, thank you. So, this will be my central atom. That will be my terminal because of the electronegativity difference. Again, when placing your terminal atoms, it should be placed around the central atom. Nakapalibot dapat, no? Huwag nyo gagawin yung yung ku. Ayan. Huwag ganyan, no? Huwag din yung ganito, oku. Huwag din yung uko. Huwag din yung ganyan, ha? Okay. So, always nakapalibot. Okay, so yan. So, since we're done drawing the skeleton, ayan, we can start using the Naso rule na. Naso rule tayo. For carbon, for oxygen. Okay, for carbon, how many electrons are needed?
8 po.
8 po. Octet rule kasi, no? Times isang carbon lang meron tayo, so times 1 na. For oxygen, ilang electrons ang needed?
8 din.
8 po because it follows the octet rule as well. Times 3 nga lang because tatlo siya. So, ilan yan? 8, 16, 24, 32. 32 electrons. Hey. Available. Available pertains to the valence electrons. Ha? So, how many valence electrons are there for carbon?
4 po.
4 po.
4. So, 4 times 1. For oxygen?
6 times 3 po.
Okay, so 6 times 3. 6, 12, 18, 19, 20, 21, 22 electrons. Okay. So, okay na ba tayo sa available? Or do I have to do something pa? Okay, so gagawin natin.
Yes.
Look. Ay, sige pa. Ay, sige. Kasi tignan mo yung molecule mo. This is negative 2, di ba? Again, when your molecule is negatively charged, that means there is an excess electron. May sobrang electron. By how much? Dalawa. Negative 2 eh. So you have to add this in your available electrons. So negative 2 yan. So that means may sobrang dalawang electrons. So you add 2 electrons na excess, making your available electrons 24 nano. Okay, so ganun yung idea. Pag negative, you add the electrons. Pag positive, you subtract the electrons. Okay, so ganun lang. So ganun ha. Ayan. S, the shared electrons. Again, the formula is N minus A. So that is 32 minus 24. 8 na. Or how many bonds? 4 bonds now. Okay, so that means we have to distribute 4 bonds around between C and O. So 1, 2, 3. Sir, paano yung sobra dito? No, no. Wag dyan. Saan ilalagay? Kahit saan. Dito na lang. Ayusin ko lang to. Okay, pwede dyan sa gilid, pwede sa baba, pwede doon. Pare-pares lang naman itsura niyan, no? Kasi pare-pares lang naman yung oxygen yan eh. Okay, so I am now able to distribute my 4 bonds around, between the atoms, no? Unavailable, unavailable. Unshared pala. Ano yung unshared, no? So, A minus S yan. A minus S. So, that's 24 minus 8. Ilan yan? 16, no? Or how many lone pairs? 8 lone pairs, no? Tama ba yung subtraction ko? 8, 16, tama. Okay, so 8 lone pairs. So I have to distribute 8 lone pairs around the sa terminal atoms muna pala, no? Terminal atoms first before the central atom. Okay, so when distributing the 8 lone pairs, you check the octet rule, no? If followed na siya. So I'll start with this oxygen with double bond, no? So how many electrons na ang meron siya? It already contains 4 electrons. 2, 4. Again, one line corresponds to 2 electrons. So 2, 4. Ilan pa kulang? 4. Okay? So yung 4 na kulang na electron, I can represent it as lone pairs. No? So 1, 2, 3, 4. And so I have 2 lone pairs na naggamit and it already follows the octet rule. 2, 4, 6, 8. So octet na siya. No? And so nagamit ko na yung dalawa sa 8 nagamit ko na yung dalawa sa 8 lone pairs na. Okay, so that means I have 6 na lang. 6 na lang kulang. Okay, so dito sa oxygen na to, how many electrons are already there? Dalawa na, no? Kasi may single bond ka. So, dalawa yung katumbas ng electron. So, that means may kulang pa akong 6 na electrons for the oxygen. Or, meaning nun, may 3 lone pairs akong idadagdag, no? Para mapunan ang pagkukulang. So, yan. So, I will add 3 lone pairs to make the electrons around it, no, equal to 8, no? So, 2, 4, 6, 8. So, yan. Okay na ako dyan. Ilan pa kulang? Ilan pa yung sobrang lone pair? Diba, 8 yon? 1, 2, 3, 4, 5. So, may 3 pa. That means, lalagay ko na lang yun dito, no? Hindi na ako magsi-circle. Ayan, no? Okay, so by placing 3 lone pairs around this last oxygen, check mo kung octet yan. 2, 4, 6, 8. So, octet na siya, di ba? Okay, so that means all the terminal oxygens are already following the octet rule. Paano na yung central atom? Bilangin natin kung octet na siya. Again, to count, you just check how many bonds ang meron sa kanya. So, this is 2, 4, 6, 8. So, may 8 electrons na nakapalibot kay central atom. Hence, our structure is complete, no? So, kompleto na siya. Complete na. So, that means we're done. Tapos na yan. Sir, di ba may mga charges yan? Mamaya yan. Kasunod yan, no? Okay, so we're pretty much done showing how to draw Lewis structures using Naso Rule. I know new to sa inyo, pero I gave you 5 examples naman to work with, no? So again, for Naso Rule, ano yung idea? You place the lone pairs muna on the terminal atoms first before the central atom. You can also form multiple bonds like that, no? Whenever you have charges, you have to account for it in your available electrons. If your molecule is positively charged, that means you have to deduct electrons sa available na. So this is positive 1, so I will deduct 1 electron sa available. If that is negative naman, you have to add the negative electrons and the negative charges now to your available. Since this is negative 2, I will add 2 electrons. This is positive 1, I will subtract 1 electron. No? So, ganun yung idea. Okay. Let's go sa last example ko. No? Last example. Kala ko 5 lang. Okay, so let's do this. HNO3. Nitric acid. Ay, naantok pa ako talaga eh. So, nitric acid. Sino yung central atom?
N po, nitrogen.
Nitrogen. Because hydrogen, hindi pwede. Oxygen, electronegative siya compared kay nitrogen eh. So, nitrogen will be our central atom. Okay, so I have many ways, no, in drawing the skeleton of nitric acid. May mga paraan ako to draw the skeleton of nitric acid. Ano yon? First way is that ilalagay ko yung mga atoms around the nitrogen. Second is ganito. Yung hydrogen kasi, ito tip ha. Tip. Yung hydrogen, pwede maging terminal ng terminal. Ayan, alam nyo na yan. No? Okay. So yan. So ano meaning ko doon? You can actually place your hydrogen at the end of the terminal atom. So para siyang terminal ng terminal. No? So you can do that. No? You can place your hydrogen at the end of the oxygen atom. Kaya nga may OH bond, di ba? Okay. Yung mga hydrogen bonding. The reason why there is an OH bond, no, is because of that, no. Hydrogen can also bond at the end of the terminal atom, especially oxygen. So yan. So ganun gagawin ko sa isa pang skeleton. Instead of writing it dito, talagay ko na lang siya sa dulo ng isang H. Siguro dito na lang. Para siyang, oh no. Ayan. Okay. So yan. So I have 2 ways of drawing the skeleton of my structure, no, of my molecule. Question, sino dyan yung tama? I don't know yet. I will do the Naso Rule muna. Hindi ko pa alam, no? So, Naso Rule tayo. Again, sulat ko muna. Okay, so for nitrogen, does it follow the Octet Rule?
Yes, sir.
Yes po. So, 8 times 1. Oxygen. Octet rule din po ba?
Yes po.
8 times 3. Hydrogen. Ilan ang needed for hydrogen?
2 po lang po.
Dalawa lang because of the s orbital. No? So, 2 times 1. So, add natin yan. 8, 16, 24, 8, 16, 24, 32, 33, 34 electrons. Available. Valence electrons yan. For nitrogen, the valence electron is 5. Oxygen is 6 kasi group 6 siya times 3. Hydrogen is 1 kasi group 1 siya. So, 5, 6, 12, 18, 19, 20, 21, 22, 23, 24. 24 electrons. Okay, so wala namang charge. So, wala na tayong gagawin. We're okay with this one na. So, S shared, that is N minus A. So, that's 34 minus 24. 10 electrons or how many bonds? 5 bonds now. So yan, so I can start distributing my bonds, no? 1, 2, 3, 4. Hala, may sobra. Lagay mo yun sa oxygen. Bawal mag-form ng double bond with hydrogens eh. Dito. 1, 2, 3, 4, 5. Ano pa? Actually, tatlo yung magagawa ko palang structure dito. Tignan nyo. Still following the same skeleton. I can place my double bond here. Dito sa NO na nakadugtong sa H. Pwede rin naman dito lang sa NO lang na to. Pag nilagay ko yung double bond dito, that is the same as this one na. So that means I have 3 possible structures for my acid, nitric acid. So yan, siguro mapapaisip ka, sino yung tama, sino yung impostor, sino yung hindi impostor, no? Yan, question mark. Okay, so ganun, question mark yan, no? Sino kaya sa tatlo ang tama, no? So, magbobotohan kayo mamaya, no? Although may sagot naman dito, no? Okay. So, sa ngayon pa lang, elimination round agad tayo, no? By just looking at the structure, sino yung mali agad? Sino yung pwede na natin i-eliminate, no? Quick elimination tayo. Emergency meeting. Sino yung impostor? Sino yung pwede na patalsikan? A, B, or C? By just looking at the structure, sino pwede tanggalin?
A po.
A? Any other votes? Okay, so ang answer ay A. Bakit si A yung kailangan natanggalin? Sige. Why A is the wrong structure? Bakit siya yung
Kasi
maling
po, ano
structure?
po, 8 na po yung bonds ng nitrogen sa oxygen.
Ilan na yung bonds?
8 na po.
8?
Ay,
Or
ayun electrons.
uh, tignan natin yung electrons dito kay nitrogen. How many bonds are there? 5. Diba sabi natin, nitrogen should follow the octet rule. Question, nagpa-follow ba siya ng octet rule dyan? Hindi. Kasi, tignan mo, magbibilang tayo ng electron. 2, 4, 6, 8, 10. So, 10 na. Lagpas na yan sa octet. So, kick out na siya na. Bye-bye. Ayan. 1 impostor left. Isa na lang. Isa na lang. Kasi between the two, may isa dapat na matira. May isa lang pwede. Okay? So, may isa na lang impostor. But anyway, since natanggal na natin yan, tapusin muna natin yung task natin. Yung unshared. No? Para tayo nag-impose. Ano tayo dito? No? Ang tawag sa game na yan? Nilalaro ko yun. Hindi ko na kasi nalalaro eh. Among Us. Okay. Ayun, so may isa pa tayong task. No? Tapusin muna natin yung unshared. natanggal na naman natin yung isang impostor. So, unshared. Again, the formula is A minus S. So, that's 24 minus 10. 24 minus 10 electrons, 14 yan, or 7 lone pairs. So, I have to distribute my lone pairs in such way that it will follow the octet rule na, no? So, masusunod na yung octet rule. So, gagawin ko muna yung kay B. Si B muna. Again, when distributing the lone pairs, terminal atoms muna, okay? For this oxygen, how many lone pairs are needed? Lone pairs,
3.
Ilan pa?
2 po.
Dalawang
Two.
lone pairs. No? And so, isa, dalawa. Okay, so by adding 2 lone pairs, it follows the octet rule na. No? So, 2, 4, 6, 8. So, we're done with that na. How about this oxygen here? Ilang lone pairs?
2 rin po.
Dalawa din. No? By adding 2 lone pairs, it already follows the octet rule na rin. No? Ayan. So, yan. Paano naging, 2, 4, 6, 8. So, octet na. Ilan ulit lone pairs natin? 7. Okay. So, 4 na yung nagamit natin. We're left with 3 na lang. For this oxygen, ilang lone pairs?
3 po.
3. 1, 2, 3. Okay, so may 3 lone pair and 1 bond. So, 2, 4, 6, 8. So, we consumed all the lone pairs na. And we're done. So, check na lang natin if octet yung nitrogen pati yung hydrogen, no? So, for hydrogen, di naman octet yung need, no? Pero kailangan ng dalawa. And okay na tayo doon, no? So, we have 2 electrons around hydrogen, no? Okay. So, for nitrogen, again, it should follow the octet. So, looking at this, we have 2, 4, 6, 8 electrons na in the form of bonds, no? So, octet na lahat ng atoms dito. Okay. So, mukhang okay siyang candidate. How about this one? Okay, so let's start distributing the lone pairs now. So, looking at this oxygen here, how many lone pairs ang kailangan or how many lone pair yung kailangan para maging octet siya?
Isa na lang po.
Isa na lang, no? So, 2, 4, 6, 8. Okay? So, may 6 pa tayong natitira. For this oxygen, ilan yung lone pairs ang kailangan?
3 po.
3. So, 1, 2, 3. So, may 3 pang natitira. And dito yun mapupunta sa nasa right side. Okay. So, yan. So, I distributed all the 7 lone pairs. And let's check kung nag-octet rule din yung H pati yung N. Octet ba si nitrogen?
Yes po.
Yes, then. Kasi 2, 4, 6, 8. Si hydrogen, dalawa lang naman kailangan eh. So, paano ba yan? Paano yan? Parehas yung structure. It seems na okay sila with octet, no? Ito yung question. Sino yung impostor dyan? No? Sige. Any guess muna bago natin sagutin. B or C? Or parehas silang crewmate?
C po.
C? Ang sabi ni Hawan, C din. Okay. So, to answer that, pupunta tayo sa next topic natin, no? Stoichiometry. The joke. Formal charges. Okay. So we will discuss formal charges. What are formal charges? No? When you say formal charge, no? Formal charge, ito yung, this is the actual charge of an atom in your molecule. No? So that means you are actually obtaining the charge of the atoms in your molecule. No? So when you add all the formal charges, that corresponds to the charge of the whole molecule, the entire molecule. No? Okay. So question is, how do you solve for the formal charge? No? So may formula na naman tayo. Fc equals VE minus, hindi, ito na lang. Should minus have para mas madali makabisado. So, in order for you to obtain the actual charge of your atom in a molecule, the formula to be used is should minus have para mabilis makabisado. When we say should, this pertains to the valence electrons. When we say have, this is the actual electrons around the atom. No? Okay, so yung actual electron around the atom. Okay, so looking at our structures, hindi. Gawa muna ako ng isang example. Okay, so looking at this structure, di ba remember na yung dalawang itong bond, this bond, it contains 2 electrons, di ba? Pero in reality, yung electrons, they can be found, no? Sa dulo-dulo, no? Sa dulo-dulo pa rin sila, no? So they just travel across along this line, no? Along this bond, no? So yun yung idea. Pero in reality, yung isang electron doon nandito kay hydrogen, yung isa nasa kabila talaga, no? So paano natin kukunin yung should minus have, no? Yung should madali lang, valence electrons. Yung have, actual electrons around the atom, okay? So paano yung gagawin, no? Ito, for beginners, the best way to do this is to draw boxes. Until now, ginagawa ko yan, na pag nakakalimutan ko yung ginagawa ko. Pero, yun, as you develop skills, no? Pag mas lalo na kayo naging malakas, no? I-mental nyo na lang yan, no? So, paano yung simple approach muna? You draw boxes. So, paano magdodraw ng boxes? Edi ganun lang. Ayan. Pero, when you draw boxes around the atom, you should cut the bonds, no? Puputulin mo yung bonds. Ayan. Puputulin mo yung mga dapat putulin. Again, when you draw boxes, you cut the bonds, ha? Okay. So, ano yung sinisignify ng pag-cut ng bonds? Meaning lang nun, that the electrons in the bond, no? Yung isa doon, nandito sa isang atom na to, yung isa nasa kabila. Okay? So, the electrons are on the opposite ends of the line, no? Are on the opposite end of the bonds, no? Okay, so yan. So, pinutol mo lang yung bond just to signify na yung electrons sa bond, no? Yung isa doon, nasa isang atom, yung isa nasa kabila, no? Okay, so ganun yung idea. Then, ano na ngayon, no? So, para makuha mo yung have, no? For you to solve for the actual electron around the atom, just look at the box, no? Tingnan mo yung box. Ilang dots or ilang electrons yung meron sa carbon. Ilang dots meron yung kay hydrogen. Ganun yung gagawin natin, no? So, siguro let's start with hydrogen first. Okay. So, formal charge should minus have. When you say should, that pertains to the valence electrons. The valence electron for hydrogen is 1 kasi group 1 siya. Have, ilang electrons meron sa isang box? Isa. Yan, isa lang. So, isang dot lang yung nakikita natin sa box na to. That means there is one half electrons na. May isang half kay hydrogen. So, 1 minus 1 is 0. So, that means this hydrogen doesn't contain any formal charge. The same is true for the other hydrogens. No? You can do it naman na. Pwede mo yung gawin-gawin na. So, yan. So, that means the formal charge for hydrogen here is 0. How about carbon? Should. That means valence electrons. The valence electron of carbon is 4. Have ilang dots meron sa kanya? Sa dalawa, tatlo, apat. So, 4. 4 minus 4 is 0 as well. Okay. So, that means the formal charges of my atoms in this molecule is 0. So, the charge of the molecule is 0 as well. Kasi again ha, when you add all the formal charges, pag pinag-add mo yung lahat, meaning nun, yun yung charge ng molecule. No? So, 0 plus 0 plus 0 plus 0 is equal to 0 na. So, walang charge yung molecule. So, ano yung tulong niya sa atin? No? The formal charge can actually help us in deciding what Lewis structure is the best Lewis structure. Sino sa dalawa yung best structure, no? So, sino yung tutulong sa atin doon? The formal charges na. So, our task now is to check the formal charges of the two molecule, no? Isa-isahin natin yan. Ay, naging green. Ay, naging blue lahat. Ay, naka. Teka lang. Balik ko lang yung... Ay, sige, okay na yan. Yan. Okay, so our task now is to solve for the formal charges of each atom in our two molecules na. So, the simplest way to do that is to draw boxes na. Pero pag nasanay na kayo, titignan nyo na lang yan. No? Paano yung technique kapag tinitignan nyo na lang? Ang technique dyan is bilangin mo kung ilang points meron sa atom. 1, 2, 3, 4. So, 4 yung half niya. Ito, 1, 2, 3, plus yung lone pair, 4, 5. So, 5 yan. Ganon din dito, no? So, isa lang yon. Ito, isa, dalawa, tatlo, apat, lima, anim. So, 6 yung half dito. Dito, ilan yung half? 1, 2, 3, 4. So, apat. Pero for now, no, for simplicity, i-box muna natin. Kaya na mag-develop ng further skills sa pagtingin na lang, no? So, yan. With practice naman, masasagutan nyo talaga yan eh. Actually, yung Naso Rule, basta alam mo na yung ano, basta gamay mo na yung structures, madali na lang gumawa na. Ano gagawin ko dito? And that's... Okay, so yan. So I am able to draw boxes around the atoms in our molecule, no? Then with that, we can actually check for the formal charges na. For this molecule, hydrogen, what is the formal charge? Anyone?
0 po.
0. Bakit? Should minus have. Should is the valence electron. So what is the valence electron of hydrogen? 1. Have, kung ilang dots meron? 1. So 1 minus 1, 0. Okay. So ayan. So thank you. This oxygen, ito. Ano formal charge niya?
0
Anyone?
po. 0 din po.
0 din po. Why? Should 6 yung should. Have, ilan yung have? 1, 2,
6.
3, 4, 5, 6. So, 6 yung have, no? 6 minus 6, 0. So, wala siyang charge. This nitrogen,
2 po.
2. 1. Okay, so the answer is 1. Bakit na? Should, valence electrons is 5. So, 5 minus have. Ilan yung dots meron siya? 1, 2, 3, 4. So, 4. So, 5 minus 4 is positive 1. So, that means nitrogen is positively charged here na. Ito na lang, green na lang. So, nitrogen is positively charged. Positive 1. How about this oxygen? Formal charge. Kita niyo pala kung umihikab. What is oxygen's formal charge?
Negative 5.
Negative 1. Bakit naging negative 1? Should 6 have, ilan yung have? 1, 2, 3, 4, 5, 6, 7. So I have 7 dots around this oxygen atom. So that's negative 1. So that means my oxygen bears a negative charge. No? How about this oxygen at the top?
0 po.
0. Should is 6. Have, ilan yan? 1, 2, 3, 4, 5, 6. So, 6, 0. So, 0 formal charge siya. Okay, so that means for molecule B, my formal charge is positive kay nitrogen and oxygen is negative. So, let's look at the other structure. I want you to find the formal charge of yung hydrogen, 0 na yan eh. 1 minus 1, 0. So, isang dot lang yan. 1 dot na yan. So, 0 na yan. How about this oxygen? Ano yung formal charge niya?
1 po.
So, the formal charge of that oxygen is 1. Bakit? 6 minus 5. What's 6? 6 is the valence electrons. 5, kung ilang dots yung meron sa kanya. 1, 2, 3, 4, 5. So, 5. 6 minus 5, positive 1. That means oxygen bears a positive charge here. How about nitrogen? Positive 1. Paano? Because valence electron is 5. Available electrons or have, ilan yun? 1, 2, 3, 4. So, 4 lang. 5 minus 4 is 1. Positive 1. So, that means nitrogen will bear a positive 1 charge na. Okay. Plus na lang pala. Huwag na yung 1. Okay, for oxygen.
Negative 1.
Negative 1. Because 6 minus 7 is negative 1. So, galing yung 6 for valence electrons ni oxygen. 7 yung dots around the oxygen. 1, 2, 3, 4, 5, 6, 7. So, 7. So, 6 minus 7, negative 1. So, that means oxygen will bear a negative charge. And lastly, this oxygen,
Negative 1.
negative 1 din. So, negative 1. 6 minus 7 is negative 1. So, 6 is the valence electrons. 7 yung dots around it. So, 1, 2, 3, 4, 5, 6, 7. So, 6 minus 7 is negative 1. Comparing the two structures, sino yung sa tingin nyo ang eliminated? B or C? Sino yung impostor? Okay, so ang impostor dyan ay si
C.
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 Ayan, si C. Bakit kaya siya yung impostor na? Kasi ganito, after solving for the formal charges, no? Pag tapos na kayo kumuha ng formal charge, may guidelines tayo, no? On sino yung the best structure, no? So actually, you can use this, this PDF file that I uploaded sa discussions page, no? May in-upload ako doon. This is the lesson that I am using in my in my SHS classes, no? SHS in college, no? Same topic lang naman eh. So yun. So yung binibigay sa college, binibigay ko rin sa senior high ko para umiyak sila. Masaya naman sila after, no? So yan. So same coverage lang, no? So anong meron dito, no? So ang meron dito is yun nga, dito yung discussion on bonding. Ito yung ituturo ng lecture nyo. So ito yung sa lab, starting Lewis structure until yan, no? So yan. Yung naming andito din sa lecture yan, no? So yan. Bakit ako hindi gumamit ng PowerPoint ngayon? Because I don't feel using the PowerPoint eh. Hindi ko feel yung PowerPoint. Medyo onti kasi nakalagay eh. Onting slides lang. So, yan, so we can use this guideline na. So, ang sabi dito, sometimes there is more than one acceptable Lewis structure. So, yan, we can have multiple structures, di ba? Just like what we did here. So, dalawa yung acceptable, no? Kasi para sila nagsasatisfy ng Octet Rule. Pero, hindi porket acceptable, tama na, no? Ayan. Okay, bakit, no? Sabi dito, we select the most plausible Lewis structure by using the formal charges and the following guidelines. So, yan. So, if may dalawang contending structures, ibig sabihin may dalawang naglalabanan for the best, no? So, magpa-pageant ka, no? Kunin mo yung mga formal charges nila. Kunin, Q&A ka. So, ito yung first guideline. Sabi dito, for molecules, a Lewis structure in which there is no formal charge, no, there are no formal charges, is preferable. So, that means as much as possible, if your molecule do not contain any charges, okay yon. Paano kung hindi possible yung wala talagang charge? Eh di yung onti lang yung charges, no? So you select the Lewis structure with the least number of formal charges, no? So kung 10 atoms diyan may formal charge, magduda ka na, no? So as much as possible, onting atoms lang yung may formal charge. Okay? So yun yung rule number 1. Rule number 2, sabi dito is that if your Lewis structure have a large formal charge, meaning positive 2, positive 3, negative 2, negative 3, they are less plausible than those with small formal charges. So what does that mean? It means that the charges should only be between negative 1, 0, and positive 1. No? So andun lang sa range na yon. Anything greater than that is questionable. Ayan. Questionable na yan pag ganun. Third rule. So among the Lewis structures, having the same distribution of formal charge, blah, 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 negative formal charges are placed on the more electronegative atom. That means if your atom is electronegative pero positive yung formal charge niya, X na yan. Maling-mali yon. So let's look, no? Tignan natin yung dalawang structures natin. So looking at our structures, yung letter B, it contains less charged particles, no? Or less charged atoms. No? Dalawa lang yung may charge, no? Compared to structure C. So first guideline pa lang, X na yung C. Because again, ano yung sabi ng first guideline? As much as possible, onti lang yung atoms na may charge, no? If kaya yung 0, edi okay. So this time, hindi eh. So ayan. So, ito dalawa lang yung may charge. Ito, 4. So, X tong 4. No? Ano pa? Second guideline. Sabi doon, the charges no, should not be at least greater than positive or negative 1. No? So, bawal yung negative 2, positive 2, negative 3, positive 3. No? So, looking at this, mukhang okay naman siya sa guideline 2. No? Pero X pa rin yung C. No? Minus ligtas point siya. Minus 1. No? Bakit? Mali siya sa guideline 1 eh. Ano pa? Guideline 3. Tatlo yung guidelines. If you have an electronegative atom, as much as possible, its formal charge should be negative, not positive. For structure B, oxygen is the most electronegative atom. So, okay lang na negative yung charge niya. Si nitrogen, since siya ay least electronegative, hindi naman siya ganun ka-electronegative than oxygen. So, okay lang yung positive sa kanya. But looking at structure C, what we can notice is that this oxygen bears the positive charge. No? Ano sabi natin? For electronegative atoms, the charge should be negative. At this time, positive yan. No? So, minus points na naman siya. So, 2 points para po kay structure C. So, with that, now we can conclude na structure C is wrong. So, mali yung structure C. So, that means our final structure for nitric acid is the structure B. No? So, yan. Structure B yung tamang sagot. No? So, to write the final answer, all you have to do, dito na lang, is to redraw it, no? Redraw mo na lang. So, yan. Pagdating ng quiz, siguro maraming structures, tas bahala kayo mamili, no? Kung sino yung tama, sino yung mali. So, yan. You redraw the structure and you place the formal charges on the atom, no? And take note, the formal charges of the atoms in your molecule, when added up, no? That should give you the charge of the molecule itself, no? So, yan, plus 1 minus 1 and 0. So, that means nitric acid is not charged now. Okay, so that's it, no? So, tapos na tayo with Lewis structures, no? But anyway, so before we end, no, balikan natin yung mga walang formal structure, ay walang mga formal charge, no? So, looking at carbonate, may negative 2 charge yan. The question is, saan kaya galing yung negative 2 charge? So, what we can do is, we can draw boxes. Ganyan na lang. Para isang burahan lang yan mamaya. Okay, so we can draw boxes, no? And start assigning the formal charges. For carbon, 4 minus 4 yan. 4 yung should. Kasi group 4 siya. Ilan yung have? Bilangin mo na lang yung points, no? 1, 2, 3, 4. So, 4 minus 4 is 0. Wala siyang formal charge. For oxygen here, ano yung formal charge? 6 yung should, kasi group 6 siya, have. Yung have, 1, 2, 3, 4, 5, 6. So, 0 din yung formal charge, no? 6 minus 6 eh. For this oxygen, the formal charge is negative 1. Bakit? Should is 6, kasi group 6 siya. Have, 1, 2, 3, 4, 5, 6, 7. So, 7. 6 minus 7, negative 1, no? So, I will write the negative charge for this oxygen. And the same is true for this oxygen, no? Parehas lang naman sila ng itsura, no? So, hence, in my molecule, in carbonate molecule, yung may mga formal charge is this oxygen, no? Ay, mga oxygen na yan. So, when you add the charges, that should give you the charge of the molecule, no? So, negative 1 plus negative 1, negative 2. Ayun ang reason bakit siya may charge, no? Because of the 2 oxygens, no? Okay. So, balikan pa natin yung isa pa. Itong NO+. Last one, no? So, NO+, no? By just
visual inspection. Tignan lang natin. So, the formal charge of oxygen here is positive 1. Bakit positive 1? Should is 6, have 1, 2, 3, 4, 5. So 6 minus 5 is positive 1. How about this nitrogen? Should
0.
is 5, have is 5, so 0 to. Sir, di ba violation yan ng guidelines? Ito yung nangyayari. If wala nang choice, wala na talagang choice na. Ganon. If your molecule, wala na siyang ibang possible structure, edi no choice siya, positive siya. So, ganun yung nangyayari, no? So, we can violate the guidelines for the formal charges if and only if there are no other possible structures. Pag isa lang yung pwede, hayaan mo na yung oxygen na maging positive even though it is electronegative. So, ganun ha. Hayaan nyo na yan. Okay na yan, no? So, ganun lang yung idea. No? So, with that, no, we're pretty much done with everything that we have to cover today. So, ano yung ginawa natin today? Lewis structure. So, let's have a recap now. So, when you say Lewis structures, these are just representations of your molecules now, where you can see the atoms bonded to different atoms now, with different number of bonds now. So, makikita mo yung bonds ng atoms now, atoms to atoms in a molecule. So, in drawing Lewis structures, we just have three rules. Actually, apat siya now. The first rule is for you to categorize your atoms. Central atom will be the least electronegative, excluding hydrogen. And the terminal atom will be the most electronegative, including hydrogen. Again, hydrogen can also serve as the terminal of your terminal atom. Pwede dumugtong yung hydrogen sa oxygen. Pwede yon, no? Kaya may hydrogen bonding. Okay? Then, after assigning your categories, you draw the skeleton. No? So, you place your central atom in the center. Your terminal atoms will surround the central atom in 4 directions. Up, down, left, right. Na. So, ganun. 4 directions lang muna. Then, after doing that, you do the Naso Rule. Again, what's Naso Rule? Needed. This tells you the Octet Rule. But not all atoms can do the octet, no? Especially hydrogen. Hydrogen can only accept 2 electrons. Okay? But for other atoms found in the p orbital, they can follow the octet rule. A available. This is the valence electrons. The valence electrons corresponds to your group number. For group 1, 1 yon. For group 2, 2, 3, so on and so forth. Up to 8 na. So 8 valence electrons. Shared electrons, these are the electrons used in chemical bonds. Each chemical bonds, they use 2 electrons. No? So yan, dalawang electrons for one chemical bond. How to determine the number of shared electrons? You just subtract the needed and the available. So by subtracting them, you can get the shared electrons. If you want to determine the number of bonds, you have to divide it by 2 lang. Unshared electrons, these are the lone pairs or the lone electrons. They are not using in bonds now. They are not used. Ay, nawala ka. They are not used in chemical bonds na. So, yan, idea. So, to solve for the unshared electrons, that's A minus S. Available minus shared, no? So, you get the unshared electrons, no? If you want to determine how many lone pairs can you make from unshared electrons, you divide it by 2 lang, na? So, yan. In case na mayroong multiple structures na possible, in such case, for example, itong last example natin, we have 3 possible structures depending on the arrangement of atoms and the location of the bonds. No? If we can do more than one structure, then we have to check the formal charge. Now, again, so formal charge, the formula is should minus have. Should valence electrons have the number of electrons present in the atom. No? So, yun yung nasa loob ng box. No? And then, once you are able to solve for the formal charges, you check the guidelines listed in this PDF file now. So feel free to download this na. Yan. So yan. You can also work with the other structures here, no? Yung mga binigay na examples dito. Okay, so ayan, no? So these are the 3 rules. As much as possible, few atoms should only contain the formal charge na. If kaya na walang formal charge lahat, edi okay yon, no? Then, if you have big formal charges, X yon. Then lastly, if your electronegative atom bears the positive charge, X din yon, no? Dapat negative, no? So, that's all. I believe na. So, mukhang okay na naman tayo dyan. So, do you have any questions about the discussion or any clarifications? Any
None po, sir.
Ha?
None po.
Anan po. Okay naman. So, if you have any questions, don't hesitate to raise them to me, ha? Kasi, ayun, nag-start na tayo ng semester, no? I mean, nag-start na tayo mag-assessments, eh. And I want to remind you na exactly 1 month from now, 4 weeks na lang, magmi-midterm exam na tayo. Yan, so college na talaga kaya, no? Midterm exam na in 4 weeks. So, yun, so I want to remind you that because yan nga, time to get serious na, no? So, yun. Galingan natin, no? So, if may mga questions kayo, don't hesitate to ask me. Hindi naman ako magwawala, no? Mas maganda na yung nagtatanong, no? Parang ano lang yan. Isipin nyo na lang yung pag-aaral is parang relationship nyo, no? If hindi kayo nagtatanungan, magkaka-miscommunication, hindi nyo maintindihan yung lesson. So, it would be better if you ask me, no? Kung ano yung ganito, ganyan. Okay, so sige. Sabi ni Jean Paula, paano po malalaman ang electronegative atoms? Okay. So, to know kung sino yung electronegative atoms, all you have to do is to check the periodic trends, no? Yung sa lecture nyo. So, paano malalaman yung electronegative atom? The trend is from left to right, the electronegativity increases. From bottom to top, the electronegativity decreases. No? So the most electronegative atom would be fluorine. No? Then, papunta sa left niya, least electronegative na sila. No? Ayan, tignan nyo. Si carbon and oxygen. Why carbon is always the central atom instead of oxygen? Because of the electronegativity. No? Kasi looking at oxygen, it is more electronegative than carbon. No? Si carbon, siya yung least electronegative. Si oxygen, siya yung most electronegative of the two. So, yan, periodic trends lang. No? Just look at the periodic table. The atom that is on the rightmost side, siya yung most electronegative. No? Yung nasa leftmost side, sila yung least electronegative. With exception to hydrogen. No? So, yun yung answer natin doon, Jean Paula. Hey, so, any questions? Or okay na? By the way, you can use this periodic table, no? Dinownload ko siya. Type nyo lang sa App Store or sa Google Play Store, no? Periodic table, then ganyan yung itsura niya. Parang auditorium, no? Ang good thing with this periodic table is that it is made by the Royal Chemistry Society, no? So, that is the Chemistry Society of Great Britain, no? Ayan. And Northern Ireland, Ireland, no? So, yan. So, gawa siya ng Great Britain and Northern Ireland, no? So, yan. So, maganda to kasi updated siya every time, no? Kunwari may bago ako ma-discover na element, makikita nyo agad yan. Gmium, no? Mga ganun. Kasi ang pangit ng pangalan na yan, eh. But anyway, so, yan. So, yan. I will upload the answers, no? Itong mga pinagsasagot natin. Then, yun. Emerge nyo na lang siya dito sa mga PDF na binigay ko. No? If you have printer, then you can print this. No? Okay, so yun lang. And what else? No? Yan, the recording of this class will be uploaded on YouTube. No? So, how to access them para sa mga nagtatanong. No? So, ganito lang. If you missed a class, you can watch the YouTube recording. So, go to your Canvas, announcements. Then, punta kayo dito sa recorded class discussions on YouTube. No? Ayan yung kagabi. In-upload ko na agad. No? Ayan. So, yan. So, you can check your section or check the chapter. Kunwari, hindi tayo nakapag-meet, no? May class suspension. Pwede kayo mag-make-up class dito na lang, no? Check na lang kayo ng ibang class, no? Ayan, so ganun. Ayan, so dun lang, ha? And you can save this playlist, no? Save nyo na lang para every time na gusto nyo mag-binge watch kapag gabi. Kunwari, hindi kayo makatulog, edi manood kayo ng ng in-org chem, di ba? Ayan, tulog ka talaga agad doon, no? So, yeah, so with that, I think we're done with the discussion, no? So, yeah, so thank you very much for waking up so early. And yan, so we are able to finish the lesson, no? Next meeting, our target is to know the exemptions, yung mga lumalabag, violations sa Naso Rule, no? Okay, so there are 3 violations sa Octet Rule. So that means we will not use the Naso Rule for them, no? So, next meeting na lang yon. And then, yung favorite nyo, molecular geometry. Madali lang to, don't worry. No? Sa una lang siya mahirap, pero mahirap pa rin siya. Na. Hindi, madali lang yan. Yung itong mga shape, no? So, yan. So, mas makikita natin yan in depth as long as you know how to draw the structures. No? So, I will upload a, a sit work, no? I mean, homework, no? So, mag-upload ako ng homework dyan sa Teams convo natin. Then, I want you to comment your answers here sa discussions, no? Just like yung ginawa ng section 8, kaso isa pa lang yung nagpapasa, no? So, yan. Yan yung homework. Babasahin ko na lang yan after. Okay, so with that, thank you very much. And sige, prepare for your next class na lang. No? So, salamat po sa pag-participate and I hope na safe kayo dyan. So, yan. Thank you very much and bye-bye.
Thank you, sir. Bye.
Thank
I'll,
you, sir. Bye po.
I'll see you on Friday. Bye-bye. Again,
Sir, bye po.
keep in mind, malapit na ang midterms. No? So, galingan nyo po. Bye-bye.
Thank you po, sir. Bye-bye po.